further less, right?
Yes, sir.
So can you compare the rate of dehydration? Yeah. So what is the rate of dehydration of these alcohols? How can we compare them? Which is going to be the fastest one and which is going to be the slowest?
Sir, C is going to be the fastest one and A is the slowest.
Yeah, because you can make the cation PHC. So this cation is tertiary as well as benzylic. So this is going to be the fastest, and followed by this one. And this is going to be the slowest one, because this cation is not resonance stabilized. This is primary carbocation. Okay. So rate of dehydration is going to be this. Okay. And which alkene you are going to make? Which alkene is formed when you dehydrate alcohols? Can you say something about it? Yeah, major alkene formed in acid catalyst, catalyzed dehydration is going to be the Setzef alkene. Right? So what's going to be the major alkene which is formed if you treat this with conc H2S? Yeah. Is it going to be this one? Yeah, I hope it is clear, the question.
Yes, sir.
Yeah. Which alkene is going to form if you carry out the acid catalyzed dehydration? Yeah.
It's the
So,
fourth one.
yeah, fourth one. How the fourth one has formed? Correct. Yeah.
I'm not sure, sir.
Pardon?
No, sir, I'm
What?
not sure how it's
Okay,
formed.
okay, okay. Okay, I will explain you. Actually, first of all, you will make a carbocation. That's clear to you. Okay. Actually, H2, the mechanism is clear. The H2SO4 will give the H plus. Okay. And the OH will get protonated and the water will be removed. Right.
Yes, sir.
So I will write it as plus H plus minus H2, leading to the formation of a cation. And then what you will do? Cation has a tendency, or always you should know that tendency. Yeah. What's that tendency is?
So tendency to remain more stable.
Yeah, tendency to rearrange and itself to become more stable. Rearrangement. Okay. So cation is going to come over here, right? And now we have two options. From here, wherever the carbocation is, you can remove the H plus by this way, okay, or by this way. Is it clear? So the other side, the left hand side is exactly same as the right hand side. So I have not considered it. I can write that also. Is it clear? So this is the major alkene which is going to form, right? So why this is the major alkene? Yeah. What's the reason? Why it's the major one? The major alkene formed in the acid catalyte dehydration is the ZZF alkene, right? ZZF alkene is the most branched, most substituted alkene. For example, this alkene, if you look here, if you mark the highlight the double bonds, this alkene is actually having 3 alkyl groups. Okay, clear? And this alkene is having 4 alkyl groups, and this alkene is having again 3 alkyl groups. So which alkene is going to be the most stable one?
Second one.
Second one. Yeah, so that is going to be the major product. Okay, that is known as ZZF alkene. And which alkene, and whatever the alkene which is the least stable, least substituted, that is Hoffman, right? Okay, clear?
Yes, sir.
And what about this one? Acid catalyzed dehydration of alcohol. This is, if you take the lowest temperature, lower temperature, what you will get? You will not get the dehydration. Okay. Actually, for ethanol, you should remember the temperatures also. Okay. But these temperatures are only for ethanol, not for all the alcohols. Okay. Ethanol is 170, 140, and 110. Okay. 170 you will have elimination, even 100, and 140 you will have ether. This is which reaction? So this is E1 elimination, which proceeds via carbocation formation. And what about this one? Which reaction is this? on the alcohol? Is it elimination? Yeah, tell me. Is it elimination reaction?
No, sir. I think
It's substitution.
substitution.
Yeah, actually, suppose what happens is once the OH is protonated, it is ready to leave. And the other alcohol which you have taken, that will come and attack on this and it will push out the water. And that's how you have ether formation. Okay, so this is substitution reaction. And elimination is if the water comes out cation form and the H plus is also there. So, but that requires a lot of temperature. Okay, that is 170 degrees. And if you take the lower temperature, it is going to be the substitution which is going to occur, right? So this we already know. This is the mechanism. That's what we discussed. Yeah. This question we did last time or not?
Yes, sir. We have done this.
Okay, we have done this question. Okay, oxidation. Oxidation is removal of H, right?
Yes,
And
sir.
in oxidation reaction, uh, first of all, you should know that the primary alcohol, oxidation of primary alcohol, secondary alcohol, and tertiary alcohol. So, what can you say about their oxidation products? First of all, you must know this, right? So, tell me what you know about the primary alcohol.
They give upon oxidation they give aldehydes and carboxylic acid.
When aldehyde or when carboxylic acid? Yeah, correct.
When
When should
the
we?
alcohols
Yeah.
are reacted with a mild reagent, it gives aldehyde, and with a strong one, it gives carboxylic acid.
Yeah, exactly. So with mild, it is an aldehyde, and with strong, it's carboxylic acid. And what are mild and strong?
So mild oxidation reagent is one which is, I think, diluted, like weak compared to the strong one.
Yeah, actually, it depends upon the medium also. Yeah. So what? Are you aware of any mild oxidizing agent?
So PCC and I think chromic acid also.
Yeah, PCC and copper heat. Okay, that is very important. Copper heat, copper additive. So PCC is what's the full form of PCC? Yeah, tell me. And what's the structure? So first of
So
all, PCC.
pyridium
Yeah,
chlorochromate.
yeah, exactly. Pyridinium chlorochromate. And you should not take the aqueous medium. You should not take water, right? So this is the solvent. Dichloromethane is a solvent which I have written. It is used to resolve PCC, and you are actually ending up with CS3CH. Okay. Clear? Right?
Yes, sir.
So what is the structure of PCC? Can you tell me? Because sometimes what they do, they give the same question but they write their structures and for the abbreviated name. And actually, we are sometimes so much familiar with the uh, abbreviated name that we don't pay attention to the structures also. So sometimes they write the structures. So what is the structure of PCC? So pyridine is a benzene ring with nitrogen, and this is pyridinium. Okay, which is proton and chlorochromate. CR. This is chloroform, right? This is the anion, and pyridinium is the cation. Is it clear? So it is going to be mild, and you will stop at aldehyde stage only. Okay, or you can use any other reagent like PDC also you can use, but you should not use water. That's the main thing as a solvent. So copper red hot tube, that's very common. Most common is this one. Okay, clear? And
Yes, sir.
what about strong oxidizing agents?
So nitric acid and acidic KMnO4.
Yeah. So if you go for let's say the most common is which are used in lab is KMnO4, acidified potassium permanganate solution, right? So that is strong. So you end up with carboxylic acid or K2Cr2O7. There also you end up with your carboxylic acid, right? Is it clear?
Yes.
And what about your secondary alcohols, 2-degree alcohols? Yeah, how they behave?
They undergo oxidation to form ketones.
They undergo oxidation to form ketone with strong and mild. Yeah. So CrO3 you should not take, whether you take strong or whether you take mild, the product doesn't get affected in secondary alcohols. Why? Why it doesn't get affected? What's the reason? That in secondary alcohol you always end up with ketone.
So there are fewer number of hydrogens.
Yeah, actually what is the concept is that this hydrogen get oxidized very easily. Okay, aldehydes have this reducing hydrogen, it get oxidized very easily, and that is the reason. Okay, why aldehyde gets oxidized, and so you should be very careful that if you are actually yeah, handling primary alcohol, whether you want to stop at aldehyde or you want to go up to acid, you should be very careful. But in secondary alcohols, upon first level of oxidation, you get ketones, but you don't have to worry because bother mostly about the further oxidation because ketones do not get oxidized easily. They get oxidized, but not normally. Okay, so the reaction stops at ketone only. Is it clear?
Yes, sir.
Okay. And what about tertiary? So ketone you can secondary alcohol you can use copper 300 degrees. That also you can use. And what about the tertiary alcohols?
They do not get oxidized.
Why they do not get oxidized?
There is no presence of hydrogen in the primary carbon.
Yeah, alpha carbon. Yeah, there is no
Yeah,
hydrogen.
alpha carbon.
So actually they don't get oxidized. Right. Okay. So this is a very, very important reaction. 300 degrees. So dehydration takes place, removal of hydrogen, and you end up with aldehydes or ketone. But actually in this case, because they can't get oxidized, but they undergo dehydration. This is not oxidation. This is for tertiary alcohol. If you use copper 300 degrees, it is dehydration which is happening. Because at such a high temperature, the water will get removed. Okay, clear? So let's do one question. Yeah. So which chapter is going on in your school right now?
Electrochemistry.
Okay. And what about solution? That is covered. Yeah. Can we take solution in the next uh, class? Liquid solution.
Hello, sir. Can you hear me?
Yeah, now I can hear you. Yeah, I was asking, can we go for solution after this? or should we go for aldehydes and ketones?
So solutions we have already started and finished, right?
I don't remember actually, so many batches are going on. Yeah. So can we go for aldehyde ketone?
Okay, sir.
That is a very important chapter also. Yeah. So we can go for that after this, right?
Yes, sir.
So what is the answer to this question? So you actually added some reagent and you got X. You don't know what is X. You don't know what is reagent. Okay. But that X which you got when you reacted it with copper 300 degrees, you ended up with the product which is shown over here, right?
Yes, sir.
So what's going to be the answer to this one? Just think. This is the A reagent and the formation of X is also related to alcohol chapter.
So fourth one.
Is it the fourth one? So actually X must be alcohol. Okay. Think in the backward direction. And if it is an alcohol, it should be this alcohol. Right?
Yes, sir.
Because suppose, so we can we can go back and we can think again, we can come back and come forward, come again in the forward direction. That's how we can cross check what we are trying to do. So this is actually the addition of water. H and OH are getting added over here, you can see. And now you tell me, this addition, is it the Markovnikov addition or anti-Markovnikov addition?
Wait, at the end, it will be OH.
Is it Markovnikov or anti-Markovnikov? So think in terms of alkene. Check the alkene. Where you're putting H, where you're putting OH. Markovnikov is rich gets richer, right?
Yes, sir.
So actually
It's
we must.
Markovnikov.
It's Markovnikov. Actually, there is one. So I'm not written. Actually, the bond line. The major concern is that the H are not shown. So what I try to do is I put the mark. I highlight the carbon, and how many bonds do I see from this carbon? 3 bonds. So if I see the 3 bond, that means one H is there, which is not written and which I have written just now by in the red color.
So it's
And
third one.
yeah, it's the one. It's the anti-Markovnikov addition of water, and we have only one way to do the anti-Markovnikov addition, right? And that is what a hydroboration oxidation I told you, right? HPO. Clear?
Yes, sir.
Right? So this is going to be the final answer to this one. Okay, so now we can come down to the ether, and this is actually the reactions of ether, but the preparation of alcohols. And so tell me, why? How do you break ethers? Why and how you break ethers? What's the mechanism? And what you get when you break the ether? So
We get alcohols.
alcohols, yeah, exactly. Yeah, suppose if I take a simple ether, let's be more specific. CH3 dimethyl ether, methoxymethane is the IUPAC name. And if you react with 1 mole of HI, what's going to happen? And if I react it with 2 moles of HI, what's going to happen? Yeah.
CH3IOCH3.
Exactly. CH3I and CH3OH. Think in this manner. H and I. Okay. Right?
Yes, sir.
But here put H on and I on the alkyl group. But in this case, where should I put I? That's not the matter of concern. Why? Why it's not the matter of concern? Where should I put I? Should I put I here or there? Because it's same on both the sides, right? That is
Yes, sir.
actually we can put I anywhere, right? So what
So
with one
means
more, what we are going to get? CH3I and what else? OH, CH3OH, right? So one alcohol and one alkyl ion. And if you react with 2 moles of HI, what will happen? This alcohol is going to react further with HI, and that will also change itself to CH3. Is it clear or not?
yes, sir.
But so the problem appears when you have unsymmetrical ethers, right? Suppose if you have this. So you are also studying CBSE at Learnivio?
Yes, sir.
Yeah, okay. So tell me now. Because this is there in your boards also. Very important question. So if I react with 1 mole of HI, how it is going to break?
So I will go with the tertiary carbon because tertiary carbocation will be more stable.
Yeah.
Like it will break easily, the bond.
Yeah, it will break easily. Yeah. So it will break easily. So it is going to be CH3OH, right? Exactly. And I, good. And what will happen if you take the 2 moles of HI?
Two ICH3 three times.
Yes, CH3I, both will become iodide because the alcohol is going to react further with the iodide, right?
Yes.
And what will happen?
So it's CH3OH.
CH3, no. With 2 moles of I, what will happen? With the first mole, this thing is going to happen. And if you have taken the second mole is going to react with HI, right?
Okay, sir.
Is it clear?
Yes,
It's
sir.
not the other way around. It's going to happen in the same way, but actually the first cleavage is going to happen in the same way, and the second cleavage actually that the second mole reacted with HI, okay, reacted with alcohol. So alcohol, water got removed, and you ended up with methyl hydride. So both will form hydride, right?
So, sir, in the first case, I mean, with the primary alcohol we have taken before this, in that also it should be I, right?
No, that should not be I. because that will only happen if you have the second mole of H.
No,
Right?
sir, in the previous example, I mean.
In previous example, one is alkyl iodide, one is alcohol, but if you took 2 moles, then both change to alkyl iodide. So here also both change to alkyl iodide, but the two alkyl groups were different. So that's why we got 2 different alkyl iodides. Clear?
Okay, sir.
Getting my point? Any doubts? You can ask me.
Got
So
it, sir.
yeah, okay. So let me put some more questions, okay, and that can make it more clear. Suppose if you have this is which ether? Yeah, which ether is this? What is the name of this ether? Very famous common name. We must know the common name. Yeah,
So methoxyphenol.
yeah, its common name is methoxybenzene. Okay, but there is a separate common name also, anisole, which is assigned to this, right? Methoxybenzene. So how we are going to react it with 1 mole of HI and 2 moles of HI? Hmm.
So the benzyl, that group, the benzene aromatic ring will break off because uh, that will form a stable carbocation due to resonance. Therefore, I will attach to
So option 1 first or option 2?
option 2.
No, not option 2. Actually, there is a difference in what you are saying. Whatever you are saying is that cation. Clear? And what we are actually, this is resonance stabilized. Okay, because it is outside the benzene, it can get the electron from the benzene, and that's how you can have the electrons. The plus charge going in resonance with the benzene. But suppose if you have a this kind of cation, is it going to be the stable one? Can it undergo resonance?
No, sir.
No, this is not the one. Okay. Is it clear?
Yes, sir.
So that is very, very important. Okay. You need to understand this. So this is benzylic cation, this is resonance stabilized, this is the phenyl cation, this is highly unstable. And let me tell you one thing, and this will give you the answer for the second one also. And it is that this bond is not going to break. The second cleavage is not going to occur. Why?
partial double bond character.
Yeah, partial double bond character. Right. So it's not going to occur. Okay. Even if you take 2 mole, 3 mole. So there are many objective type questions where they ask you how many moles of HI will be consumed. Okay. So in this case, actually, I will go for the first cleavage of the first bond, not the second. Okay. So if I cleave the second bond, the one which is on the left hand side, I'm going to get a highly unstable cation which is not stabilized by resonance. But before that, I should not cleave the second bond at all, because the it's already having the partial double bond character, right? And if it is already having partial double bond character, it's not going to come out so easily, right? So that's the problem. Okay. So, so what should I make here? Now tell me. As a product, what should I write? Yeah.
So phenol and CH3I.
Yes. Yeah. So in the above cases, what we discussed, if we took 2 moles of HI, both alkyl groups got converted to iodides. Okay. But in this second case, what is going to happen? Tell me. Yeah.
So the hydrogen will in the hydrogen which is attached to oxygen in the phenol will be replaced by iodine.
No, actually nothing is going to happen. Same answer in this case. Right? Why? Because this is aromatic alcohol and the OH is actually resonance stabilized. It is not going to come out so easily. That's the problem. Clear or not?
Yes, sir.
So even if I have written 2 mole, but the above cases are different. There the 2 mole they will react. But in this case, if I have written 2 moles, the 1 mole will not react at all. There is no use of taking 1 extra mole, because that phenol is not going to react. And we have studied it in that alkyl halide chapter also. There, in alkyl halides, actually what we have seen was the alcohol's aromatic. We have seen various methods to convert the alcohol to alkyl halide, which included thionyl chloride, reaction with HI, reaction with phosphorus halides, okay, red P plus I2. And there you must have noticed that all those reactions were not applicable for aromatic alcohol. They were applicable only for aliphatic alcohol. Okay, right? So
Yes,
this is
sir.
the thing which you need to consider. Okay. Now tell me one more thing. So I hope this is clear to you. What will happen with this? Yeah.
CH3I, CH3, CH2OH.
With 1 more? Yeah.
Yes, sir.
So this is going to be SN1 or SN2 reaction?
SN1.
Not SN1, SN2. Because you are reacting, the I minus is attacking on the smaller alkyl group. So if the nucleophile attacks the smaller alkyl group, where it happens? Does this happen in SN1? No. In SN1, actually, the nucleophile attaches itself to the more branch because the carbocation was more stable there. In this case, it's the I minus has attacked on the smaller alkyl group, and where the smaller alkyl group is attacked by the nucleophile, that is SN2. Is it clear or not?
Yes, sir.
So it's happening by SN2 reaction. Okay. And what about this one? This is just normal. Both will turn to iodides. Just you should be careful only if one group is phenol. Okay. And O is directly connected to benzene, that is not going to get flipped. Is it clear? Right?
Yes, sir.
Okay. So that is very, very important. Now, you can see over here, it can be SN2 or SN1. Okay, so this is the mechanism what we discussed just now. The first thing is HI protonates the oxygen, and the I minus prefer to go and attach itself to the smaller alkyl group, that is SN2 reaction. Okay, and if you have taken the 2 moles of HI, the alcohol is going to react further, and the I is going to attack again, and the ethyl is also going to change to HI, right? But in this case, what we have discussed, it breaks on its own. Getting my point? You can see here, this one. After the protonation of OO, it breaks easily. It breaks on its own. Why? Why it breaks? Because it is giving a stable carbocation. So if it breaks and form a cation, that is SN1. Is it clear?
Yes,
So
sir.
this mechanism has proceeded by SN1, but it will break only if the carbocation formed is stable like tertiary, okay, or like benzylic PHCH2 plus. But if the carbocation is not stable, then we are going to they will not break. Then I will prefer to attack on the smaller. If they break before the attack of I, okay, if they break before the attack of I, right? That is SN. Is it clear?
Yes, sir.
Okay. So how you are going to make ethers? What is so this is breaking of ethers, and how you are going to make ethers? What's the method to prepare ethers?
So one I think is concentrated H2SO4 at certain temperature.
Yeah. Suppose if I give you CH3, CH2, and if I ask you to convert it into, using a suitable set of reagents, convert it into CH3, CH2, O, CH2, CH3. Yeah, you said concentrated H2SO4. But you need to be careful with the temperatures. If you take more temperature, that is going to undergo elimination reaction. So for ethanol, we remember the temperature. But for other alcohols, we don't remember the temperature. We need to do it experimentally, okay? We need to check. So at 170, I told you to remember this. At 170, you will have ethene. But at 140, you will have ether. Is it clear?
Yes, sir.
Yes, sir. But what's the other method? Suppose if I don't give you H2SO4, how we are going to convert it into? You can use other reagents. To convert it into an ether. Yeah. Tell me. So you can divide it into two parts. First is you can treat it with any Na or NaOH. What is going to happen? Is it clear?
Yes, sir.
So this is alkoxide, ethoxide, ethanol, and this is ethoxide. So this is one part of the story. The second part of this alcohol is treated with red P plus I2. Okay. So what you are going to get? What is red P plus I2? Yeah, Mamsi, tell me.
So I think we'll get alkyl halides.
Yeah, alkyl halide. Yeah, it is P. It is equal to Pi3. Okay. And remember, we written three OH group and three Pi3. You remove H3PO3 and you connect I2OH in place of OH. So this is just the reverse method. Now whatever we are doing is just actually the reverse of the first. You cleave ethers using HM, but here we are making them. So I turned one of the from the alcohol. So I turned one of the alcohol into alkoxide ion and another alcohol into alkyl halide. And now I put them together. So this is the nucleophile, right? This is going to come and attack at this position. This is a leaving group, and that's how you are going to have it. Is it clear? Which mechanism is this?
SN2.
Yeah, this is SN2. The most famous question which come to our mind is, and which this is also a common part between the alcohols and alkyl halides, that how you are going to make this ether, methyl tertiary butyl ether. Are you going to choose yeah, what's going to be the answer? What's the suitable way?
So I think the second method.
Yeah, why second method? This is the correct. This is incorrect method. Yeah. Why second?
So because it is 1 degree alkyl halide, and therefore the reaction would SN2 mechanism would be
Be
preferred.
very fast. Yeah. And what about this one? What if you would have taken this first option? What you will get? Will you get this ether?
No, sir, because it has a very big uh, hindrance. Therefore the process won't take place.
Then the process won't occur, and what you are going to get? You are going to get. You are going to get some different thing. Okay. So some other process is going to occur. What that is? So is the substitution going to occur? That you already told?
No,
No,
sir.
because it's very difficult. So, but elimination can happen here because it is a strong base. And in elimination, that CH3O minus is not going and attaching itself to the carbon. Instead, it is removing the H from the position adjacent to the carbon. So in this case, you are not going to get this. Instead, you will end up with an alkene. Clear?
Yes, sir.
Right? So I hope this is clear. Okay. So that is very, very important part. So now, tell me, let's start with the aldehyde ketone chapter. Okay. So we can go through the some more thing. Test you know for to identify the alcohols. What all test you know? You can tell me quickly. Suppose if you have an alcohol and an ether, how you are going to identify? Whether it is an alcohol or an ether, how you are going to identify it? Yeah, laboratory test. Hmm. Yeah, Vamsi.
So P plus I2.
No, but P plus I2, how it is going to tell you whether it is an alcohol or an ether? That's the reaction of an alcohol. Yeah, tell me.
So iodoform test, I guess. We can use I2 in the presence of NaOH.
Yeah, I2 and NU is good. So if it is giving negative iodoform test, what it means it is an ether. And if it is ethanol, then so this CH3 is going to come out as CHI3. What's the color of CHI3?
So red.
No, yellow PPT. Right? That's how we are going to get it. Okay. But there is one very small test also. You don't have to take hydrogen. Put sodium. Clear? And what you will observe? Tell me. If it is an ether or if it is an alcohol, what's the difference you are going to observe upon putting sodium? Yeah, Vamsi. Very simple. If it is an ether, dimethyl ether, or if it is an alcohol, what the difference are we going to observe? Yeah, tell me.
So can you repeat again?
So I ask you to tell me what will happen if it is an ether and you put some sodium into it, and what will happen if it is an alcohol and you put some sodium into it. Yeah.
So ether will become into CH3ONA and CH.
No, actually ethers will dissolve sodium. The sodium will be dissolved, right? It doesn't break actually. And you must have remembered the Woods reaction. In that we use sodium diether, right?
Yes, sir.
That is for the dissolution of sodium. So sodium is going to dissolve. Okay. But no chemical reaction will occur because that ether O minus ONA is going to that is going to, the carbon oxygen bond is bit stronger. It's not going to break so easily. But what about this one? Can you tell me what may have occurred here if it is an ethanol?
So the same reaction would occur here. Because O minus and Na
Yeah,
plus.
this one is CH3O CH2. This is acidic hydrogen, right?
Yes, sir.
So sodium is going to replace the acidic hydrogen, okay? And what in what form it is going to appear in front of us? Hydrogen gas, right? H2 gas will be liberated. Okay. So what's the test? Simple test. But this test actually is not applicable for all, just for alcohol and ether. That's it. Whether if you are given that it is an alcohol or an ether, you can apply this. So can you conclude what are the observations? Yeah, Vamsi.
Yes, sir. When the substances is reacted with sodium, then if it is ether, then there'll be no liberation of H2, no
Yeah,
reaction will take place.
yeah,
And if it is alcohol, the reaction will take place and H2 will be liberated.
yeah, exactly, right? And but suppose if you have three alcohols, one is primary, secondary, and tertiary, then this sodium test using sodium is not going to work at all. That we know because all three are alcohols. Then what we should do?
So we can use Lucas reagent.
Yeah, there we use Lucas test, right? Exactly, right? So now let me talk more about let's start with the preparation of aldehyde and ketone. Okay. So what Do you, so is it covered in your CBSE, aldehyde ketone? Yeah, tell me.
No, sir, it's not.
Okay, so, or we can do the chapter which, any chapter which you want. But aldehyde ketone is an important chapter also. That also we can cover. So shall we start with aldehyde ketone?
Okay, sir.
So what are aldehydes? What's the difference between aldehyde and ketone?
So aldehydes are terminal function groups, and ketones, they occur between the chain.
Yeah. So this is an aldehyde, right? Smallest aldehyde is which one?
Formaldehyde.
Okay. And what about ketone? Yeah. And what about ketone? Yeah.
So methanol.
A ketone actually, aldehyde, you have at least one side you have hydrogen, on the other side you have carbon. At least, or hydrogen on both the side connected to CO. In ketone, actually, you have carbon on both the sides. Is it clear?
Yes, sir.
But there should not be any other functional group. Okay. There should not be any other functional group. Suppose this is what? Is this a ketone or an aldehyde? Yeah, tell me. So ketone, actually you need to have two alkyl groups on two sides of the CO. This is also carbon. Alkyl groups only, cyclic ketone. But this is neither an aldehyde nor a ketone. This is not an aldehyde because other side you need to have a carbon group. This is not a carbon group, oxygen. This is oxygen. Okay. And this is which functional group, if we can recall it? Yeah. Tell me. Which functional group is this? These are esters. Clear?
Yes, sir.
Ester. So you need to have only carbon and hydrogen. That's it. No other group. If you have only, if you have hydrogen, at least one hydrogen and one carbon on one side, that is an aldehyde. But if you have two alkyl groups on two sides, that is a ketone, right? Clear?
Yes, sir.
Ketone, and this is an aldehyde. So what's the name of IUPAC name of this? This is an aromatic what? Aldehyde or a ketone?
Aldehyde.
Yeah, so what's the IUPAC name? Or first we can try this one. What's the IUPAC name of this aldehyde? This is bit easy and that one is difficult. So we can try with this one. Yeah.
So 2-butanol.
Butanol. No. Actually, you're going to start the numbering 1, 2, 3, and 4. Longest chain giving lower number to aldehyde. So 4 carbon atom but. There is no double bond in, and the suffix for aldehyde is al, butanol.
So 2-methyl is there, right?
Yeah, that is the main word root and the suffix. And what will come in the prefix? So whatever is not included in the parent chain. So I have written the name of this portion, and this is substituent. This is going to come in the front, right? So 2-methyl butanol. Is it clear?
Yes, sir.
And what about this one? This is bit difficult. This is an aldehyde, and actually if the cyclic ring, if it is connected directly, that is called benzene carbon diide, right? Is it clear?
Yes, sir.
It's benzene carbon diide. So benzene carbondiide is also known as benzaldehyde. It's the common name is. Benzaldehyde. Okay. Right. And what's the IUPAC name of this compound? So that's the common name, benzaldehyde, and benzene carbondiide is the IUPAC name. Okay. And what's the IUPAC name for this compound? And what's the functional group?
Ketone is the functional group.
Yeah, it's ketone. Correct. That is because CO is in the middle, so you have carbon on both the sides, so it is ketone. Now, which ketone is this? What's its name? Yeah, tell me. Now, what's the name of this ketone?
I'm not sure.
Yeah, the same thing you are going to use. Okay. You need to do the numbering, right? You can use the numbering such that it gives the lowest number to the ketone, which is the main functional group 1, 2, 3, 4. Right? I did the numbering from this side. In aldehyde, I did the numbering from that side. Why?
So because the aldehyde is it's placed at that side.
Yeah, it was placed. So I need to choose the side which gives the lowest number to the principal function. Okay, clear?
Yes, sir.
So yeah, so
3-methyl butanol.
yeah, it is 2-butanol, right? Butane, that was butanol, but butanol you don't have to write 1 because you know that it is the aldehyde is on the terminal carbon, right? Butane 2 on, right? And what else?
3-methyl.
3-methyl butane 2 on, right? Correct. What about this one? Now, what's the name to this? Tell me. This one. Yeah. Your answer. Tell me. So first of all, you need to select the main chain. Okay. This is the main chain.
So 4 ethoxy, 2 methyl, X, 1
Yeah. The main chain is
X,
cyclohexane.
1 on.
Cyclohexane. Cyclohexane or hexane? Yeah, 1 on.
Hexene.
Yeah, 2, 3. I will do the numbering 1, 2, 3, 4 from the double bond. First, I give the priority to the principal functional group, then to the double bond. Right?
Yes, sir.
So cyclohex 2 in. And that's the name of the encircled portion. In on, 1 on. Right? That's the name of the encircled portion, including the double bond O. Yeah, now I will cover up the side chains which are written in the prefixes. Okay, so what are the side chains? Yeah, they are present at the second position and the fourth position, right?
Yes, sir.
So what name should I write over here?
So 2 methyl, 4 ethoxy.
4 methoxy.
Methoxy.
Yeah, which one should I write first? So substituents are written in alphabetical sequence. So METH is same methyl and methoxy. O comes before prior to Y. So I took wrote O before Y. Methyl. Clear?
Yes,
Right?
sir.
So that is an name of this ketone. This is a ketone, which is the principal functional group, and ether is the substituent. Right? Okay. Among aldehyde and ketones, which is principal functional group, if you have aldehyde and ketone also, both are present.
Aldehyde.
Aldehyde is a principal functional group, right? So what is going to be the name of this one? Yeah. And what's the prefix? Actually, for the principal functional group, you're
Sir,
going to
2-oxo
yeah,
butanol.
yeah, 2-oxobutanol, correct. So the principal chain and the principal functional group is aldehyde, that is butanol, and that is 2-oxo, right? 2-oxobutanol. Okay. So this is the common introductory part, and the benzaldehyde is very common, the common name. The other, so it is an aromatic aldehyde. And the other two most common ketones, this is acetophenone, the common name, and the benzophenone. So benzaldehyde, acetophenone, benzophenone, these three are the very common aldehydes and ketones common name. Okay, so that you should remember, right? So next is the preparation, and that we are going to look at it on the next turn, right? So let's meet on the next turn with more questions. So what is covered in your CBSE till now?
So they are doing electrochemistry now.
Okay, and what was covered till now in CBSE?
So solutions chapter and
Yeah.
haloalkanes and haloarenes.
Okay.
And after that, it was phenols and ethers.
Okay.
Uh,
And
and now it's so electrochemistry.
yeah. And what is the when are your school examinations? That I think you can do it, right?
Yes, sir.
Okay. So just keep on practicing more questions so that you can get more practice. Which book you are using?
So I'm using NCRT, but I have also Arihant, sir.
Okay, Arihant is there, right? Arihant, which one?
So I have a JEE Arihant practice material.
Okay, good. Yeah, you can do that also. And any problem you can ask me. Okay,
Okay, sir.
let's meet on the next turn, right? So let me in today's class. Okay, bye bye. Take care. Good night.
Thank you, sir.
Yeah, bye.